When scientists saw the pictures, they were shocked. The far side looked completely different than the near side. It's saturated with craters. It just was such a huge dichotomy. Nobody was expecting that at all. So, one of the biggest mysteries in planetary science over the last about 50 years is, why is the crust to the far side so thick? The moon, a beacon in the night sky, has captivated humanity for millennia. But what mysteries does its hidden face hold? Today, we are going beyond the familiar to explore the dark side of the moon. This lunar landscape, bombarded by meteors for billions of years, is a treasure trove of craters, mountains, and what else? Could there be more to the dark side than meets the eye? Join us as we explore the latest discoveries, lingering theories, and embark on a captivating journey to unveil the moon's best-kept secrets. Debunking the dark side myth. With a little help from binoculars or a telescope, the moon transforms from a distant orb into a world etched with craters and splotches of color. But there is a curious fact about our lunar companion. No matter how you look at it, you're only ever seeing one side. This begs the question, what secrets might lie hidden on the opposite side, the one that perpetually faces away from Earth? The term, dark side of the moon, often conjures images of a mysterious and unknown land, shrouded in perpetual darkness and facing the vast emptiness of space. It sparks the imagination, leaving us to wonder what wonders or oddities might exist on this unseen side. Perhaps there are alien landscapes bathed in the faint glow of distant stars, or maybe it's a desolate wasteland ravaged by solar winds. However, astronomers tend to wince a little whenever they hear this term used. They understand its popularity. After all, even the legendary Pink Floyd album title made it a cultural touchstone. But the widespread use of dark side also creates a lot of confusion, and here's why. Firstly, the fact that we always see the same lunar face is a consequence of something called tidal locking. We'll delve into that fascinating phenomenon later. But the biggest culprit for the confusion? It all boils down to the terminology itself. So let's unpack this misconception and discover why dark side might not be the most accurate term for the hidden face of the moon. The moon's dual nature. The term dark side throws a bit of shade, literally and figuratively, on our understanding of the moon. As mentioned before, it paints a picture of a world eternally shrouded in shadow, a stark boundary separating the illuminated side we see from an abyss of perpetual darkness. But this simply isn't the case. While it's true there is always a part of the moon that's not bathed in sunlight, it's not a fixed region. Just like Earth, the moon experiences a day and night cycle. Imagine yourself as an astronaut stationed on the moon's surface. You wouldn't be stuck in an unending night. You would witness the sun majestically rise above the lunar horizon, casting its light across the landscape before eventually setting and giving way to a starry night sky. Here's the key takeaway: the dark side of the moon isn't truly dark all the time. It's more accurate to think of the moon having a day side and a night side, just like our planet. The day side basks in the sun's glow, while the night side is cloaked in darkness. But here's where things get a little tricky. The side of the moon we see from Earth can sometimes be the day side and sometimes the night side. It all depends on the specific lunar time when we look up at it. To clear up the confusion, a more precise term exists: the near side and the far side. The near side is the permanent face of the moon that is always pointed towards Earth, regardless of your location on Earth. The far side, as the name suggests, is the opposite side, perpetually facing away from us. Even if you hopped on a plane from New York to Sydney, Australia, just to peek at the moon from the other side of the planet, you would still see the familiar lunar features we've all come to know. Both the near side and the far side experience the dance of day and night. They both get their share of sunlight during the moon's journey around Earth. The crucial point is that we simply can't see the far side, even when it's bathed in sunlight, because it's always turned away from our gaze. So the question remains, what's the reason behind seeing only one side of the moon? We'll explore that fascinating connection next. The force behind the moon's perpetual face. The moon takes about 29 days to complete one full revolution around Earth, and interestingly, it also takes about 29 days for the moon to spin once on its axis. This remarkable coincidence, where the rotation and orbital periods align perfectly, is the key to understanding why we always see the same lunar face. Imagine the moon not spinning on its axis. In that scenario, as it travels around Earth, we would eventually see every side of its surface. But that's not what happens. The culprit behind this synchronized rotation and orbit is a force called tidal locking. Earth's gravity exerts a stronger pull on the side of the moon facing us and a weaker pull on the far side. This gravitational tug creates a stretching effect, ever so slightly slowing down the moon's rotation over time. Eventually, the moon reached a point where it takes the same amount of time to rotate once as it does to complete one orbit around Earth. In simpler terms, the moon became locked in its position, always presenting the same side to Earth. However, there's a twist. Due to a wobbling motion called libration, we can actually see a little bit more than 50% of the moon's surface over time. Libration allows us to peek around the edges of the near side, occasionally catching glimpses of the far side. But it's important to note that these glimpses are limited. Because of the moon's locked orientation, we can never see the far side directly head-on. We can only observe it from an angled view, which makes detailed observation quite challenging. Unraveling the mysteries of lunar asymmetry. Our journey to the moon has revealed a curious asymmetry. The two sides of our lunar companion look remarkably different. The near side, the familiar face we see from Earth, is dominated by vast dark plains called Maria, which is Latin for seas. Early astronomers, mistaking these features for bodies of water, gave them their current name. In contrast, the far side presents a heavily cratered and rugged landscape. Here's where the mystery deepens. The near side has 31.2% of its surface covered in Maria, while the far side holds a mere 1%. Scientists have been puzzling over this stark difference for years, and a few fascinating theories have emerged. One theory points to the heat factor. Geochemical maps created using data from lunar missions suggest a higher concentration of heat-producing elements on the near side. These elements could have played a role in volcanic activity, leading to the outpouring of lava that eventually solidified into the Maria. While other factors, like surface elevation and crust thickness, might influence volcanic eruptions, they don't explain why the far side's South Pole Aitken Basin, the moon's lowest point with a thin crust, wasn't as volcanically active as the near side's Oceanus Procellarum. Another intriguing theory proposes a celestial collision. Some scientists suggest the far side's unique appearance might be a consequence of a massive impact with a smaller moon, a leftover from the same collision that is believed to have formed the moon itself. This impact could have created a thick layer of material on the far side, explaining the abundance of craters. However, this theory faces a challenge. The chemical composition of the far side doesn't quite match the expected makeup of such a collision. The crater disparity itself is another interesting observation. Initially, scientists thought the Maria on the near side might be obscuring craters, creating the illusion of a smoother surface. But calculations show that Earth only blocks a tiny portion of the moon's sky, making it an unlikely shield from impacts. The prevailing theory suggests that while both sides likely received a similar number of impacts, the near side's resurfacing by lava flows buried many craters, leaving them unseen. The latest research sheds light on the role of Earth's heat during the moon's formation. It suggests that the near side cooled down slower, leading to a thinner crust. This thinner crust allowed meteoroid impacts to penetrate more easily, triggering volcanic activity and the formation of Maria. In contrast, the far side, cooler due to its position away from Earth, formed a thicker crust. Earlier impacts on the far side would have had a harder time breaching this thicker barrier, resulting in the heavily cratered landscape we see today. Finally, the far side boasts a more dramatic roller coaster ride in terms of elevation. The moon's highest and lowest points, along with its tallest mountains, all reside on this hidden face. This uneven terrain further adds to the moon's fascinating asymmetry, offering scientists a glimpse into the moon's complex geological history. Charting the far side of the moon. Our fascination with the moon's far side goes way back. Before the era of space exploration, it was a realm of pure speculation. Some imagined it as a perpetually frozen and ominous wasteland. The truth, as with most things in science, proved far more captivating. The far side remained a complete mystery until October 1959. That's when the Soviet space program made history with their Luna 3 probe. This ingenious spacecraft managed to swing around the moon, capturing the first ever glimpse of the hidden face. The images, though grainy, revealed a surface dramatically different from the familiar cratered plains of the near side. The next major leap came in 1962 with NASA's Ranger 4 mission. Designed to crash land on the moon, Ranger 4's mission had a dual purpose: gather as much data as possible before impact and provide a wealth of images and telemetry. Although a system malfunction prevented the camera from working, the mission was still considered a success. The orbiter sent back invaluable data about the lunar surface and environment. Fast forward to 1968, when the Apollo 8 mission made history. As the first crewed spacecraft to venture beyond Earth's orbit, it carried 3 brave astronauts around the moon. They became the first humans to witness the far side of the moon with their own eyes, capturing the iconic Earthrise photograph, a stunning view of our planet rising above the lunar horizon. Our exploration of the far side didn't stop there. In 2012, NASA launched the Gravity Recovery and Interior Laboratory (GRAIL) mission. These twin spacecraft, named Ebb and Flow, were tasked with mapping the moon's gravitational field. This mission provided detailed information about the moon's interior structure, helping scientists better understand its geological history. Then, in 2019, China achieved a significant milestone with its Chang'e 4 mission. This historic mission marked the first successful landing on the moon's far side. Equipped with a lander and a rover named Yutu-2, Chang'e 4 continues to explore and analyze the far side's surface, sending back high-resolution images and valuable scientific data. These missions have collectively revealed the far side's rugged terrain, abundant craters, and unique geological features. One particularly fascinating region is the South Pole Aitken Basin, the largest and oldest impact basin on the moon. It's a prime area of interest for scientists studying the moon's history and the early solar system. The far side's exploration has expanded our knowledge and fueled our curiosity about the moon's past, its formation, and its ongoing geological processes. As we look to the future, upcoming missions promise even more exciting discoveries. In conclusion, our journey to understand the moon's far side has come a long way since those early speculative days. From the first tantalizing glimpses captured by spacecraft to the groundbreaking missions of recent years, each step has unveiled new mysteries and deepened our appreciation for our lunar neighbor. The far side of the moon, once a realm of unknowns, has become a key piece in the puzzle of our solar system's history. As we continue to explore and unlock its secrets, we gain valuable insights into the processes that shape not only the moon but also our own planet and beyond.